There's a particular kind of silence that exists in aerospace programs, not the silence of something finished. In 2023, Russia delivered 2 widebody passenger aircraft. 2. Boeing, in the same year, delivered over 300. Airbus delivered more than 700. Now, you could look at those numbers and draw the obvious conclusion that Russia's aviation industry is broken, that sanctions killed it, that Western pressure did exactly what it was designed to do. And you wouldn't be entirely wrong. But you also wouldn't be seeing the whole picture. Because what's happening inside Russia's aerospace program right now isn't a story of collapse. It might be a story of the most calculated industrial gamble in modern aviation history. And at the center of it is an engine that doesn't fully exist yet. The Aviation IL-96 was born in the final years of the Soviet Union. It first flew in 1988, and from a pure engineering standpoint, it was genuinely impressive work. For turbofan engines, wide twin-aisle cabin, transcontinental range, it was Russia's answer to the Boeing 747 and Airbus A350, the defining widebody jets of that era. But here's what changed. The aircraft that the IL-96 was designed to compete with, they're being retired now. The A340 is essentially gone from most major fleets. The 747 passenger variant is nearly extinct. Not because they were poor aircraft. Aviation historians will tell you they were beautiful machines. But because the economics shifted beneath them quietly at first, then all at once. When the Boeing 777 proved that a twin-engine widebody could cross oceans safely and reliably, the calculation for 4-engine jets changed forever. ETOPS, Extended-Range Twin-Engine Operational Performance Standards, the regulatory framework that governs how far twin-engine aircraft can fly from an airport, kept expanding. 180 minutes, then 207, then beyond. Suddenly, the safety argument for 4 engines on long-haul routes became less about necessity and more about preference. And airlines don't operate on preference. They operate on margins. 4 engines means 4 times the maintenance cycles, 4 times the inspection requirements, 4 times the part inventories, 4 times the line mechanics who need to know exactly what they're doing. The A380, one of the most aerodynamically sophisticated aircraft ever built, is being parked by airlines not because passengers disliked it, but because finance departments ran the numbers and winced. The IL-96 faces a version of the same structural problem. So when Russia announced the IL-96-400M, an updated, extended variant of this same airframe, the reaction from most Western aviation analysts was roughly predictable. Some were skeptical, some were dismissive, and almost all of them asked the wrong question. The wrong question is, will airlines want to buy this airplane? The right question is, what is this airplane actually for? And those are 2 very different things. When Russia's state aviation industrial complex decided to revive and modernize the IL-96, they knew the commercial landscape better than outsiders assumed. They weren't delusional about the market, but they were solving a different problem entirely. Consider what Russia's aerospace engineering community faced after the Soviet collapse in 1991. Within roughly a decade, the institutional infrastructure that had built competitive widebody aircraft began to hollow out. Engineers moved to other industries. Some emigrated. Design bureaus lost funding. Supply chains contracted. And the aircraft manufacturing plants, enormous, complex facilities that required constant use to stay functional, began to idle. Here's something that rarely gets discussed outside aerospace circles. Manufacturing capability isn't static. It doesn't sit quietly in a warehouse waiting to be reactivated. It lives in people, in institutional memory, in the daily problem-solving of experienced engineers who know where the tolerances are, where the metal behaves unexpectedly, where the process breaks down and why. When you stop building widebody aircraft, you don't just pause production. You begin losing the living knowledge of how to build them. The Voronezh plant, Russia's primary widebody manufacturing facility, needed to be kept operational, not as a museum, as a functioning organism. The IL-96-400M is In a very real sense, the machine that keeps that organism breathing. Now we reach the part of this story that most coverage completely misses. Because the IL-96 program is ultimately not about the IL-96. It's about an engine called the PD-35. And understanding what that engine represents requires understanding how difficult it actually is to build one. Modern high-thrust turbofan engines, the kind that power the Boeing 787 Dreamliner and Airbus A350, operate in conditions that genuinely push the boundaries of material science. Inside, the high-pressure turbine temperatures can exceed 1,500 degrees Celsius. That's not a rounding error. That is hotter than flowing lava. And the blades rotating in that environment, they aren't rotating slowly. They're spinning at thousands of revolutions per minute under enormous centrifugal stress, in heat that would turn conventional steel into a softened, failing structure within minutes. The materials that survive this environment, single crystal nickel superalloys, thermal barrier coatings applied at atomic precision, these aren't off-the-shelf components. They are the product of decades of specialized metallurgical research. Building an engine in this thrust class, the PD-35 is targeting approximately 35 metric tons of thrust, puts it in direct competition with the GE9X powering Boeing 777X and the Rolls-Royce Trent XWB on the A350. These are engines that GE, Rolls-Royce, and CFM International spent billions of dollars and decades of sustained research developing. Not hundreds of millions, billions, not years, decades. And they built that capability starting from an already advanced industrial base, with access to global supply chains, unrestricted access to materials and manufacturing expertise from across the world. Russia is attempting something comparable, under comprehensive Western sanctions, with a compressed industrial base, and with a timeline measured in urgency rather than comfort. As of the mid-2020s, the PD-35 remains in early development and ground testing phases. A full prototype is not expected before 2027 at the earliest. Certification, the process by which aviation authorities verify an engine is safe and reliable enough to carry passengers, remains years beyond that. The gap between where the PD-35 is and where G9X or Trent XWB technology currently sits is significant. But what surprises many analysts is not that the gap exists. It's that Russia is still closing it at all. Before 2022, Russia's commercial aviation sector was deeply, comprehensively integrated into the Western aerospace supply chain. Russian airlines flew Boeing 737s, Boeing 777s, Airbus A320s, A330s, Western engines, Western avionics, Western maintenance software, Western certification standards. It wasn't just that Russian carriers preferred Western aircraft. It was that the entire operational infrastructure, the maintenance training, the spare parts logistics, the airworthiness procedures, the regulatory frameworks, had been built around them over 30 years. When sanctions arrived in force following 2022, the disruption wasn't simply that new aircraft couldn't be delivered. It was deeper than that. It revealed that Russia's civil aviation sector had no independent capability to sustain itself at anything resembling its existing scale without continuous access to Western components and expertise. Avionics, landing gear actuators, engine components, even basic maintenance consumables. Russia had made a bet, implicitly over decades, that integration into the global aerospace system was more efficient than maintaining independent capability. That bet made rational sense in the 1990s, in the 2000s, even into the 2010s. And then the conditions changed almost overnight. What happened next matters, not because Russia's response has been flawless, but because of what it shows about the limits of aerospace dependency. The PD-35 program, already underway before 2022, suddenly transformed from an industrial development priority into something closer to a national security emergency. The question shifted from, can we eventually build a competitive high-thrust engine? To, can we build one at all, before our commercial aviation capability irreversibly degrades? Here's something worth knowing. When GE Aviation was developing the GE9X, the engine that now powers Boeing's 777X, they didn't wait for the production aircraft to be ready before they started flying the engine. They mounted prototype G9X engines on a heavily modified Boeing 747, a 747 that would never carry passengers with this engine. A 747 that existed for one reason: to accumulate real-world flight data. Because testing an engine in a ground cell tells you certain things. Flying it tells you different things. Things about how it behaves in actual atmospheric conditions. How thermal gradients shift between climb, cruise, and descent. How the engine management systems respond to real turbulence. How the materials perform over thousands of cycles in conditions you cannot perfectly replicate on the ground. The flying testbed concept is one of the most valuable and most underappreciated tools in large engine development. Russia is running a version of the same playbook. The IL-96 program serves as the platform, keeps the Voronezh plant active. It gives Russian engineers a real widebody to build, certify, and iterate on. It preserves the institutional knowledge, the tooling, the supply chain relationships, the manufacturing muscle that any future Russian widebody program will desperately need. And when PD-35 reaches a testable state, the IL-96 airframe provides an obvious platform to begin accumulating flight data in real conditions. This isn't improvisation. This is a long-view industrial strategy that most outside commentary is reading too shallowly. The IL-96-400M is not Russia's answer to the Airbus A350. Everyone who frames it that way is looking at the wrong aircraft. The actual endgame, the program that Russia's aviation strategists are building toward, is a clean-sheet, twin-engine widebody. Modern architecture, contemporary aerodynamics, powered by two PD-35s. Something capable, at least in theory, of operating in the same market space currently owned by the 787 and A350. But that aircraft cannot exist without the engine. And the engine cannot be developed without engineers, facilities, and institutional knowledge that remain active and accumulating experience. The IL-96 is the bridge. The thing you build not because you intend to cross a river in it forever, but because without it you cannot reach the other side at all. Whether that bridge holds long enough for the PD-35 to mature into something genuinely competitive. That is the central uncertainty of this entire program. No analysis of Russia's widebody ambitions is complete without accounting for China. The CR-929, a joint project between Russia's United Aircraft Corporation and China's COMAC, was announced with considerable fanfare. A twin-aisle widebody designed to compete directly with the Boeing 787 and Airbus A350. Russian engineering expertise meeting Chinese manufacturing scale and market access. The PD-35 was, at various stages, proposed as the Russian engine contribution to this program. That partnership has since encountered serious difficulties. China has been exploring alternative engine options. The relationship between the two programs has become complicated by diverging industrial interests and technological priorities. But zoom out from the CR-929 specifically and consider what the broader picture implies. China has explicitly, repeatedly, and with enormous financial commitment stated its intention to reduce dependence on Western aerospace systems. Its own large commercial engine program, the CJ-1000A, is advancing toward certification for the COMAC C919. Chinese aerospace investment across the board is accelerating. Russia, meanwhile, retains genuine engineering depth in certain areas, even under significant constraints. What Western aerospace analysts are actually watching not in public commentary, but in serious industry assessment, is whether a credible, capable, non-Western widebody engine ecosystem could emerge by the early to mid-2030s. Not a perfect ecosystem, not one that immediately challenges GE or Rolls-Royce for every contract, but one capable enough to serve large,